I tell you the phone.
All right. Good morning.
Yeah.
So So look at number 6 of yesterday's question, numerical methods. I'm surprised to see you here. It's not Lano.
It's not Lano.
It's Lano now.
It's not Lano.
Okay, it's Lano.
It's Lano.
Please don't listen to Sam.
Lano.
Okay, so let's solve one problem on this and just move on. Look at number 6. It says evaluate 1 over 1 plus x, the x from 0 to 1 using trapezoidal and Simpson's rules with h equal to 0.5, 0.25, 0.125, correct to 3 decimal places. So you are going to try here with each of them. So they want you to solve with each of these values. So let's pick the one as h equal to 0.25. Okay, that's quite easy. So you can do for each of them. So we're going to use trapezoidal rule. We are going to use Simpson's rule also. Then we'll compare the result. You see which one is more accurate. Okay. So in this case, please pay attention now. Your a is equal to 0 and b is equal to 1. Does that make sense? That means that x naught, you can also say x naught is equal to 0. All together. And if you are given h, in this case, you are given h to be 0.25. An alternative to this is you are given n. Okay, you may be given n. N is the number of intervals. Okay? If you are given n, you will use it to find h. Here you have h already. So you can use it to find n. So you are going to use that to get the number of intervals that you need. Okay? And don't forget that I told you yesterday that if you want to get the size of each interval, h, it is equal to b minus a all over n. Does that make sense? Can you remember this? Okay? So in this case, you have been given h to be 0.25. So this 0.25 equal to b, which is 1, minus a, which is 0, all over n, which is what we want to get. So that means that our n is going to be 1 over 0.25, which is meant to be 4. So that means in this case, our n, number of intervals, is 4. Okay? So if the number of intervals is 4, this is what that means. That means we're going to have to find out x naught, x1, x2, x3, x4. Okay? So in this case, I can call this, please pay attention, I can draw a table and say n, then xn, then yn, where yn will just be equal to f of xn. Alright, so you can do this table, just write out the values first, then we'll make use of the values later. So I can start with n naught, that is 0, 1, 2, 3, 4. So the number of ordinates, like as I told you yesterday, the number of ordinates will be 1 higher than the number of intervals. So I have the intervals to be 4. So the number of ordinates is obviously 5. Is that making sense?
Yeah.
So what is my x naught? So I'm going to start with 0. Okay. H is the size of the interval. So if I start with 0, the next number, the next value will be 0 plus 0.25. Abi? So that's going to be 0.25. The next one will be 0.25 plus 0.25. That is 0.50. The next one will be what? 0.75. And lastly, 1.00. So it should usually go from A to B. Do you understand that? If you have done the interval, if you have interpreted the interval and ordinates correctly, you should go from the first value in the interval. The first value here is 0 to 1. So what we are doing basically is that we have tried to divide this. So I told you something yesterday that this means we want to get some area under a curve. I have decided to divide the curve into 4 portions. So you have a portion here, you have a portion here, you have another one here, you have another one here. Then we say that this is our x0, this is x1, x2, x3, and x4. So how we sum these elemental areas will now depend on how accurate, or will determine how accurate our results will be. You can see that it's obvious that the smaller your interval, the more accurate your results is going to be. Okay? And now, so we have gotten all of this. We can get our values 1 over 1 plus x. What's it going to give us for each of them? So when x equals to 0, this is 1, Abby. When x equals to 0.25, just enter it in your calculator and just press calc. Oh yeah. 0.8. 2 over 3. That's 0.6667. Let's leave it at 2 over 3, yeah. And 4 over 7. 4 over 7. And 0.5. 0.5. Alright. So that's what we have. So this is going to be our y0, y1, y2, y3, y4. Do you get that? Right. So we can now use the rule we want to use. So whatever rule you want to use, whether it's trapezoidal rule or Simpson's 1 over 3 rule, you first have to list out the values this way first. You understand me? So then after this, how you will use these values will be determined by the rule you are employing. So in this case, we want to make use of Simpson's rule first. Okay, let's try trapezoidal rule first. Trapezoidal rule. Can you remember trapezoidal rule? I gave you the rule yesterday. Figure from A to B, or we say that from x0 to x0 plus nh of some function y is equal to f of x, that's y dx, okay, is equal to, what's the formula please? What's the formula? H over 2,
open brackets,
H over 2 into
y not plus y
2 open brackets.
is y ended
y1 plus y2 plus yn minus 1
then plus yn
plus yn. Alright. So that's trapezoidal rule. So that's what we're going to use here. So what is the meaning of all of this? If you are going to start from y0, you're going to end at yn. Then the intermediate values between y0 and yn will be multiplied by 2. Does that make sense to you?
Yes.
So in this case, we have our y0 to be this 1. Yn, that's y4, because in this case our n is equal to 4. Can you remember? N is equal to 4. Is that clear? So our yn is y4. So therefore, for our problem here, integral from 0 to 1 of f of x dx, which f of x in this case is 1 over 1 plus x dx. This is going to be h over 2. What is h? Is 0.25. So this is going to be 0.25 over 2 multiplied by y0. What's y0? 1. Then plus 2 into y1. So we're going to have y1, y2, y3. All together, y4 will be outside because that's the last. Is it making sense?
Yeah.
So that's going to be 0.8 plus 2 over 3 plus 4 over 7, then plus 0.5. This will be out here. So you can punch this in your calculator. What does it give you?
Calculators.
Was he calculated? Was he calculated?
Yes.
0.697. Alright, that's that. Now you know that your calculator can actually evaluate the integral directly, right? Now if you enter the integral directly on your calculator, what does it give you? Don't forget to put in the intervals 0 to 1. Do it with your calculator directly. What does it give you? I know you can't give it that. You can't give it 697. It should be something close to it, but not exactly.
0.693146.
Okay, 69314. Okay. So if you are given this kind of problem in the exam, what determines whether you can use calculator or not is you first look at the options. If the options are far apart, maybe they gave you something like 0.69 something, they give you 1 point something, the other one is minus chemical point something. You already know there's no need to do all of this long approach. If the values are very far apart, do you understand me? It's when the values are very close, like decimal differences between them, then you will have to actually do it to know the exact value it is. Do you understand me? But if the differences are not decimal, you can just use your calculator directly, then pick the one that is close to it there. Does it make sense to you? You get what I'm saying? Alright. So you can also use your Simpson's 1/3 rules. Yeah.
Why were you adding the value of each to each?
H to each XN. Okay, to get XN, Abby. H simply means the size of this interval. This is the meaning of H, the distance from this first one to the next one. That's the meaning of H. If I want to get this, I will add it to this one, get the next one, get the next one, like that. So that's the meaning of H, the size of the interval. Did you get that? Alright, so in this case 4, n is the number of intervals, and n plus 1, 5 is the number of ordinates. So that's why we have y0, y1, y2, y3, y4. Okay. Now we move on. So you should get the use the other rule now. What is the Simpson's 1/3 rule? Simpson's 1/3 rule.
Another one again.
Now you might be given n, you might be given the number of ordinates. If you are given 5 ordinates, you know n is equal to 4. Okay.
We'll give you n.
The relationship between n and h is b minus a over n equal to h. Take note of this. B is this upper number and a is this lower number. That's the difference. That's the relationship between n and h. Number of ordinates and the size of each interval. Okay? I mean number of intervals and the size of each interval. Alright, so for Simpson's 1/3 rule. Simpson's 1/3 rule. What is that going to be? It says that x to x0 plus nh of y dx is equal to h/3. Give me the formula.
H/3
Into
y0
y0 plus 4 into
y1 plus y3.
y1 plus y3 plus and so on and so
Yeah,
forth.
plus
Plus y into n minus 1, right?
Yep.
Then plus 2 into y2 plus y4 plus and so on and so forth, plus y into n minus 2, then plus yn. Okay. So the idea here is that all the listen. They are going to exclude the first and the last. Okay, they are going to be outside, separated from the others. Just like this one, the first one and the last one, they are outside, separated from the others. But now, for these values between y0 and yn, you are going to multiply those ones that are odd, those ones that have odd subscripts. You are going to multiply them by 4. And the ones that have even subscripts, you multiply them by 2. Does that make sense? Eh? Oh, this is the y2, y4. Alright. The ones that have even subscripts will be multiplied by 2. The ones that have odd subscripts will be multiplied by 4. Then you put out the you separate out the first and the last. Now notice that this is h/3. This one is h/2. So notice the differences there. So in this case, we're going to have our integral from 0 to 1 of 1 over 1 plus x dx to be equal to h is 0.25 all over 3 into y naught, still 1. Okay, that's 1. Then plus 4 into, so what are the odd ones now? That's just y1 and y3. So that is going to be, y1 is what? 0.8, Abby. Then plus y3. Y3 is what? 0. That's 4 over 7. That is 4 over 7. Then plus 2. We'll pick the even ones. Excluding the last one. Are we together? We're excluding the first and the last. So the only even one left is y2. That's going to be 2 into 2 over 3. Then plus the last one outside. That is 0.5. So then we close this bracket. So what does this
Okay,
equal?
so we're not going to put y4.
No. I said first one and the last one, they have to be outside. Did you
The
get that?
y4 that is inside super.
Yeah, this one is assuming that the ends are greater than 4. Do you understand me? Or the n in this case is greater than 4. Do you understand me? You didn't get what I just said? This one happens when n is greater than 4. It's just to show you the pattern. Now you are taking the even numbers. Are we together in this case? But in this case, it's not up to that. Do you understand me? So 4 is the last one. That means our n is 4. So it will rather be at this end. It won't be inside here. Do you understand this?
Yes.
Yeah, what's the answer? 0.693. So you can see that this is more accurate. When you enter this now, Abby?
Yes.
0.693. You can see it's more accurate. It's closer to the actual answer compared to that one. And that's that. And you can get even more accurate results if you use a smaller value of h. So that's the idea with this method. So let us, yeah.
No, it's not.
They are different.
Like when you start
Decimals are different. The decimals are different. Did you notice 693 is 697? So that was what I said earlier, that if you are given this problem and the values are far apart, use your calculator to do the integral directly, you pick the answer and move on. Do you understand me? But if the values are close, you have to do it so that you will know the exact number. Okay. So look at number 8. So the others, number 6. So you can check, please pay attention, number 6. You can solve the same problem using h to be 0.5. So it's the same approach, it just reduces the interval. You can also solve it with h equal to 0.125. That just increases the number of intervals you have. And then you can also try your hands on number 7 with 5 ordinates. That means n will be equal to 4.
Yes. N will be equal to 4.
Yeah, n will be equal to 4. With n being 4, you can solve the problem.
So not 5.
N is the number. N is the number. N is the number of intervals.
So the 5 is what?
What is the number of ordinates?
That's like 0, 1, 2, 3, 4.
You know when you have 4 intervals.
Oh, that's 5 now, you guess. Like 0, 1, 2, 3, 4.
He said what interval is 1 plus. Yeah, that's what he said. He said the interval is 1 plus. Ordinate is 1 plus.
Ordinate is 1.
Ordinate is 1 plus.
Imagine they're telling me things there.
Just like this.
So look at number 8. Suppose that, look at number 8, please. Suppose that f of 0 is 1, f of 0.5 is 2.5, f of 1 is 2, f of 0.25 is equal to f of 0.75, and is equal to alpha. Find alpha if the trapezoidal rule with n equal to 4 gives the value 1.75 for integral from 0 to 1 of f of x dx. So this is still numerical method, but now you have been given this as an unknown. You have been given alpha as an unknown, and then you are not given the actual function. So this is just to test if you really understand the numerical method approach. Can I wipe this? Can I clean this?
Yes.
Okay.
The last question. Number 9.
That's not same thing. That's the same thing.
And it's true.
What is it?
But something is usually close to the answer. So, this can
So
be-
in this case now, look at it. So they said trapezoidal rule with n equal to 4. If we will use trapezoidal rule, please pay attention, pay attention. Look at the question, number 8. You have this integral to get, you want to get this integral from 0 to 1 of f of x dx. Okay, so in this case, your a is 0, your b is 1. So with Simpson's rule or whatever rule you want to use, with n equal to 4, you're going to have your size of the interval, h will be equal to b minus a over n. This will be equal to 1 minus 0 all over 4. So this is what? 0.25. That's the size of the interval. Are we together? So if this is the size of the interval, what will be the ordinates? We are going to start from 0, Abi? Aha, so the ordinates will be x0 equal to 0, x1 equal to 0.25, you know the same, we just keep adding h, and then x2 equal to 0.50, x3 equal to 0.75, and x4 is equal to 0. That's 1.00. Does that make sense? Alright, so those are the ordinates you have here, 5 ordinates altogether. Then you have been given these values. You know that you need to get y naught. Of course, y naught simply means f of x naught, right? Okay, so you have been given that value. They said that f of 0, because our x naught is 0, f of 0 is 1. You don't see that there? Then you have also been told that f of 0.5. So you know the next thing you need to be f of 0.25, Abi? You are also given that. They told you f of 0.25 is alpha. Can you see that? They said f of 0.25 is same as f of 0.75 and it is alpha. So that means that we can write that out. Our y1 is going to be equal to alpha. Does that make sense? Okay. And then what's our y2? Y2 will be f of 0.5. So from what we have been given, they said f of 0.5 is what? 2.5. Is that clear? Is this clear?
No, just come over.
What's the issue now? Look at the values you are given. Y naught is f of x naught. That's f of 0. They told us f of 0 is 1. Can you see that there?
Yes.
Y1 is what? Y1 will be f of x1. That is f of 0.25. Can you see that in the question? What is f of 0.25 in the question?
Look at the end.
Number 8. What are you looking at?
Number 8.
What
Like,
is
sir,
f of
it's
0.25?
It's not really showing here except you.
No, you actually equated it to F0.75.
And
It's
then
equal to
on the other
alpha,
side, it's
the
equal
other
to
side.
alpha. Can you see it? Have you seen it?
Yes.
Can we move on now? Okay, so y2 is f of x2, Abi. What is f of 0.5?
2.5.
2.5, Abi?
Yes.
That's how we came about this. Is that clear?
Yes.
So what's y3?
0.75.
0.75. That's f of 0.75.
Yes.
So what's f of 0.75? Alpha. Alright. Then y4 is what? F of 1, Abi?
2.
What is f of 1? 2. Okay, so
Okay, we are just going to
equal
go
to
about
2. So we are good to go now. So they said that when you use trapezoidal rule with n equals to 4, it gives the value 1.75 for the integral. Are we together? So when you use the trapezoidal rule,
Yeah.
you should remember the trapezoidal rule means that integral from 0 to 1 of f of x dx, okay, say a to b of f of x dx, or say x naught to nh, our general formula now, x naught plus nh is equal to h over 2 into y naught plus 2 into, so I just want to write it for this. That will be y1 plus y2 plus y3, then plus y4. Is that clear? Is this clear?
Yes.
Alright, so we can substitute now. So they told us that this is 1.75. That means 1.75, please keep quiet, is equal to H is 0.25. So this is 0.25 over 2 multiplied by y naught. What's y naught? Y naught is 1 plus 2 into y1 alpha plus y2. Y2 is what? 2.5. Y3 alpha plus y4 2. So we can now solve this equation for alpha. Does that make sense? Alpha is the only unknown here. So what is alpha? Yeah, solve. Having fun.
That's not what I'm thinking. Maybe. Like sounding like this.
Alpha now.
Alpha.
Do you understand what we're doing? We came too early.
Principal. Sir, you know it already, Jerry.
This one is very simple, sir.
Yes.
What is it? You gave us in the question. What's y1? Y1 is f of x1. F of 0.25. You gave us in the question.
You made the assumption of y not equals to f of x.
No
Y is equal to
assumption. You gave us in the question.
You made the assumption of y not equals to f of x.
Yes. So that's that. Go and practice all that. What did you get it to be? Alpha is what? What is alpha? 0.18. 0.1875. For alpha.
I got 1.57, sir.
I'll get different answers.
You just calculation, no, not anything.
Check what you have done again. This one is too simple for
Today.
you to make that kind of. Imagine that you have suffered so long then. Then you miss it at this point and then you find it in the option. You know, if you miss it here and the option is not there, you will still go back and check what you have done. But if the option is there, you just happily choose the option.
Yeah. So what is y1?
1.5.
I get 2.
You're going to get this.
See, the 1.5.
What did you get? 1.5. 1.5. These people that said it will not me. All right. So let's talk about the next topic, series.
Long for me get time.
Yes, sir, let's continue. Just at the back.